I want to prove that the limit as x approaches 6 of 3 is equal to 3. The first thing I'm going to do is look at the difference between my function and the limit. And we want that to be less than epsilon. So my function here is 3. My limit is also 3. So the absolute value of 3 minus 3 is less than epsilon. So we have 0 less than epsilon. So in this case, because we got 0, any delta is going to work. Let's look at a graph. So if I were to graph y equals 3, and we look at x equals 6, no matter how I choose delta, so let's say if I have some delta that's greater than 0, no matter how I choose delta, think of my f of 6 plus delta or f of 6 minus delta, the y value is always going to be on this line, the line y equals 3. So the difference between the x value and 6 is going to be less than delta, but my y value is always going to be 0 because it's always going to be 3. So that guarantees my limit, my difference between my function and my limit to be less than epsilon, since this thing is always going to be 0. Let's look at a similar one. Let's say if I have limit as x approaches 2 of -1, we start off with the absolute value of f of x minus my limit being less than epsilon. My function is -1, my limit is also -1, and so I get 0 is less than epsilon. So again, no matter what delta I choose, f of x minus my limit is always going to be less than epsilon. And we can see in the graph of y equals -1, at x equals 2, any value close to 2 is always going to be -1. So no matter what value of x I choose, the difference between my function and the limit is always going to be 0, and that's obviously less than epsilon, because we choose epsilon to be greater than 0. So always we choose epsilon to be greater than 0 for these proofs. Okay. Let's look at a cube root now. Let's say I have limit as x approaches 0 of the cube root of x, and we want to prove that the limit is equal to 0. We're starting off with the difference between my f of x and my limit less than epsilon. My function here is cube root of x, and my limit is 0. So I can get rid of the 0. I want to get x by itself, so I'm going to cube both sides. So the cube root and the cube cancel, so I'm just left with the absolute value of x less than epsilon cubed. And we're going to choose delta to be epsilon cubed. So we're going to say let delta equal epsilon cubed. By definition, I want to start with x minus my constant c here less than delta, and c is going to be this value 0, and delta we said is going to be epsilon cubed. Now x minus 0 is just x. I'm just going to rewrite it like this for convenience, and I'm going to cube root both sides because I want to get epsilon. So we can raise it to the 1/3 power. And really, we can just rewrite it as the cube root of x. And then minus 0 because, again, that doesn't really change anything. It's less than epsilon because now this is f of x minus my limit. And you may be wondering, why can't I take the cube root inside the absolute value? So let's take a look at that. So let's say, what's the difference between cube root of x, like this, and the absolute value on the outside, and cube root of absolute value of x? Well, if they're both positive, I think it's pretty obvious why they're the same. But okay, let's say this. If x is greater than or equal to 0, on the left side we just have the cube root of x. And really you could just remove the absolute value because that's going to be greater than or equal to 0. You don't need, that just disappears. And then the absolute value of x is just x, right? Because the absolute value of x is defined to be negative x if x is less than 0, positive x if x is greater than or equal to 0. Okay, so that works. Now if x is less than 0, here I'm going to multiply by negative. So it'll be the cube root of x like that. And this will just be cube root of, now x is positive, so we'll have to put it like this. So because x is negative, negative x will be positive. And here we could just pull out the negative. We can think of it like -1 times x cube root, and that will just be cube root -1 times cube root of x, and that'll be negative times cube root of x, which is the same thing that I have here. So that's why. Okay, so that was a little tricky. Let's look at a absolute value now. So if I have an absolute value function, I want to prove its limit. So let's say if we have limit as x approaches -5 of absolute value x minus 5, we know that this limit is going to be 10. So I take the difference between my function and the limit, and I want that to be less than epsilon. My function is x minus 5. My limit is 10. Okay, so this is where it gets tricky. I have absolute value x minus 5, and x here is approaching -5, right? So x is -5. So I go back to the definition of absolute value. So we know the absolute value is defined to be a piecewise function. We can remove the absolute values if x is greater than or equal to 5, and we have to multiply by negative if x is less than 5. And because I'm looking at x equals -5, that's going to be in this top case, right? -5 is less than 5. So I can rewrite this absolute value here as negative x minus 5, and then minus 10 less than epsilon. So then we can distribute out the negative. We get absolute value negative x plus 5 minus 10 less than epsilon, and that's negative x minus 5 less than epsilon. Okay, here I can factor out the negative, so it'll be negative times x plus 5 absolute value, and this negative could come outside. Could come outside as like a -1. So it's like -1 absolute value, and then absolute value of x plus 5 less than epsilon. This just becomes 1, so you're just left with absolute value x plus 5 less than epsilon. Okay, and now we're going to choose delta to just be epsilon. So that's kind of nice. So we're going to say this is, so delta is going to be epsilon. So we're going to say let delta equal epsilon. I want the absolute value of x minus c to be less than delta. C here is the x value that we're approaching, and we're approaching -5. So it's x minus negative 5 less than delta, but delta we chose to be epsilon. Okay, let's continue. We have absolute value x plus 5 less than epsilon. And we can rewrite this as bringing the negative inside as negative times x plus 5. And here I'm allowed to do that because the negative, we can pull it out and that becomes positive. We can distribute the negative. We have negative x minus 5 less than epsilon. And we know negative 5 is the same thing as 5 minus 10. Okay, and let's see. So here we're just working up backwards. So you're probably wondering how I'm getting all these. Well, I'm just working up backwards like this. Okay, so I have negative x plus 5 minus 10. So we're over here. And now I can factor out the negative. So it'll look like this. I can factor out this negative. It'll be x minus 5 after. And we know that the negative times the quantity x minus 5 is just the absolute value of x minus 5. So that was based off up here. So this right here. Right, so we're going this direction. So we're given that the negative times quantity x minus 5, that's the same thing as absolute value x minus 5, since we're looking at x at negative 5. And now we finally have the absolute value of f of x minus my limit is less than epsilon. And that finishes the proof.